I'll start question 1 by using the first piece of information. The mean of these three numbers is equal to 11. So I have x plus 10 plus y over 3 is equal to 11, which means that x plus 10 plus y is 33. So x plus y is equal to 23. And then I have a second piece of information about the range. Y minus x is equal to 7. The maximum minus the minimum is equal to 7. Now I have two equations. Let's label them 1 and 2. I'm going to solve this simultaneously. Y plus x equals 23. Y minus x is equal to 7. If I add the two equations, I get 2y is equal to 30. So y is equal to 15. And then if I substitute this value in an equation, I'm going to do that in equation 1, I will get x plus 15 equals 23. So x comes out to be 8. I'll start question 2 by sketching the box. The base area is equal to 2 times 1.25, which is equal to 2.5 square meters. Then, to find the force exerted by the box on the table, I will rearrange the formula. Pressure equals force over area to get the force on its own, and force is equal to pressure times area. So in our case, it's 42 times 2.5, which comes out to be 105 newtons. I will start question 3 by first calculating the number of candles produced. I've got 6.3 kilograms. This is 6,300 grams. I will divide this by 210 grams for each candle, and this will give me 30 candles. Some of them are sold for 13 and some of them at a reduced price. So let's split my page into two. 30 times 2 over 5 will give me 12 candles, and these 12 candles are sold at 13 each, and this will give me 156. And then I have 18 candles, which are the rest, at a reduced price. To find the reduced price, I will do 13 times 0.8, which is my multiplying factor due to the 20% reduced price. This will give me 10.4. So 18 candles times 10.4. This is 187.20. So the total amount received is 156 plus 187.20, which is 343.20. Question 4, part A, expanding will give me 3c minus 21 plus 6c plus 8. And if I simplify, I will get 9c minus 13. In part B, I've got x squared minus 2x plus 7x minus 14. Collecting like terms will give me x squared plus 5x minus 14. Question C, common factor of 7y times 4y minus 3. And finally, in part D, 7x minus 2 equals 4 times 3x plus 1. So 7x minus 2 equals 12x plus 4. 7x minus 12x equals 4 plus 2. So minus 5x equals 6. So x is minus 6 over 5. For question 5, I will use the formula distance equals to speed times time. I've got my time here. Note that this is equal to 6 and 42 over 60. I can write this one as 6 and 7 over 10, or even a 6.7. So my distance is equal to 650 times 6 and 42 over 60. Be careful when entering this on the calculator. So if you do put it on the calculator correctly, you will get 43.55 kilometers. For question 6, first note that an interest rate of 1.5% gives me a multiplying factor of 101.5 over 100, and as a decimal, this is 1.015. So the total amount of money in the account at the end of 3 years can be found by 20,000 times my multiplying factor to the power of 3, because I have 3 years, and this will be 20,913.57, and to the nearest integer, this is 2914. For part A, I can cancel out the 20 with the 4, and I will have a 5 in the numerator. Then note that the x's are both squared, so I can cancel them out. And then for the y's, I've got y to the 6, y squared. I will subtract the powers, so 6 minus 2 will give me 4. So the final answer is 5y to the power of 4. For part B, to get E on its own, first I will write H minus F equals to 3E. So E is equal to H minus F over 3. For question 8, I will first sketch a rough diagram. I will start from point A and drawing the north. Then I move 200 meters due east to point B, and then 160 meters due south to point C. And I need to work out the length of AC. Now this is a right angle triangle, so to work out AC I will use Pythagoras theorem. AC squared is equal to 160 squared plus 200 squared, which comes out to be 65,600. So AC is the square root of that, which comes out to be 256 to 3 significant figures. In question 9, I have a regular pentagon, a regular octagon, and an isosceles triangle. I need to work out the angle X. I will start by finding the interior angle of the pentagon and the interior angle of the octagon. Then I will find the third angle at that point, and then I will use the isosceles triangle to find X. Before we begin, let's remind ourselves of the formula of finding the interior angle of a regular polygon. So angle 1 is equal to 180 times 5 minus 2 over 5, which is 108 degrees. Angle 2 is equal to 180 times 8 minus 2 over 8, which is 135. Then angle 3 is 360 minus the previous two angles. This comes out to be 117, and then x is equal to 180 minus 117 over 2, which comes out to be 31.5 degrees. In question 10, I will split my trapezium into a rectangle and a right angle triangle. I will extract this right angle triangle. Now, the height of this triangle is 12.5, and the base of this triangle is 24.3 minus 16, which comes out to be 8.3. Now, to find angle theta, I will use tan. So tan theta equals opposite, which is 8.3, over adjacent. So theta is inverse tan of this fraction, and theta comes out to be 33.6 degrees. So angle x is equal to 90 degrees plus 33.6, which gives me 123.6 degrees. In part A, I need to write the modal class. This is the class with the highest frequency, which is 100 to 200s. In part B, I need to complete this cumulative frequency table using the information above. So that's 10, 46, 80, 100, 115, and 120. And in part C, I need to draw a cumulative frequency graph for the data above. Remember, my x coordinates are the upper bounds of my groups, and the y coordinates are the cumulative frequency. Note that the lower bound of each group is 0, so my graph is going to cut the x-axis at 0. And then I need to draw a curve through these points. In part D, I need to use the graph to find an estimate for the interquartile range. Interquartile range is equal to Q3 minus Q1. Now Q3 is 120 times 3/4, which is 90th value. Q1 is 120 times 1/4, which is the 30th value. Now from the graph, Q3 comes out to be 350, and Q1 comes out to be 160. So IQR is 350 minus 160, which gives me 190. Now for part D, I need to find an estimate for the number of families that spend more than 450 pounds. This time I'll start from the x-axis. The value I find on the y-axis is 108. Now these 108 spend less than 450, so to find the number of families that spend more than 150, I will do 120, which is the total, minus 108, which comes out to be 12 families. Now, since the graph is not unique, each student can get a different graph. There's a range of acceptable values for parts D and E, and according to the mark scheme, for part D is 175 to 205, and for part E is either 12 or 13, as long as it follows through from the graph. In question 12, I need to work out the size of angle ADC. It's the angle I marked X. Now, to do so, first I should recognize that angle BAO is 90 degrees. That's the angle between a tangent and a radius. And also BCO is 90 degrees for the same reason. Then I will work out the size of angle 1, I marked in red, and then X is half the value of size 1, because angles at the center is twice the angle at the circumference. So let's begin to find 360 minus 90 plus 90 plus 74 is equal to 106. So X is equal to 106 divided by 2, which is 53 degrees. For question 13, let's first remind ourselves of a rule regarding perpendicular lines. Now, if two lines are perpendicular, the product of their gradient is -1, and this can be arranged to get M2 equals -1 over M1. It's like saying M2 is the negative reciprocal of M1. So the first equation, this one here, has a gradient of -2. This means that M2 has a gradient of -1 over -2, which is a half. And then since line L2 passes through 4, 7, its equation will be y equals a half x plus c. 7 equals a half times 4 plus c. So c is equal to 5. So y is equal to a half x plus 5 is the equation of line L2. Now this equation crosses the x-axis. If it crosses the x-axis, it means that y is equal to 0. So 0 equals 1 over 2x plus 5. So minus a half x equals to 5. X equals to -10. So my answer is -10, 0. In question 14, I will convert everything to power of 2. Note that 128 is 2 to the 7, and 4 is equal to squared. So I've got 2 to the power of 7 equals 2 squared, all to 2x times 2 to the power of x. So 2 to the 7 is equal to, and then I'm going to multiply these powers. So 2 to the power of 4x times 2 to the x. And now these two powers will be added together. 2 to the 7 is equal to 2 to the 5x. So if I equate the powers, I've got 7 equals to 5x. So x is 7 over 5. In question 15, note that these numbers represent the number of elements. So number of elements in A union B is this one here, and I've got 19 elements. When I do the addition, I get 19. Now A complement intersection C, I need to be outside A and inside C. So outside A are these numbers from these four regions. Inside C are only these two. So 4 plus 1 is equal to 5. And then finally, A complement union B complement. So this means either outside A or outside B. Outside A, I've got these numbers. Outside B, I have these numbers, either purple or red. So if I add this up, I get 29. In question 16, I select 3 counters out of the 8. I add the 3 numbers, and I want the total to be an odd number. Note that when I add 3 numbers, for the total to be an odd number, I only have 2 possible combinations, either 3 odd numbers or 1 odd number and 2 even numbers. The probability of getting 3 odd numbers is equal to 5 over 8, because there are 5 odd numbers, times the probability of 4 over 7, because if I'm selecting 3, it's like selecting without replacement, so one of them is gone, times 3 over 6, and this comes out to be 5 over 28. Now, in order to get 1 odd number and 2 even numbers, I have to take into account the order of selection. So here I've got probability even, even, odd. I've got probability even, odd, even. And I've got probability odd, even, even. Now note, to get an even, even, and then an odd number, I've got 3 out of 8 times 2 out of 7 times 5 remaining odd numbers over 6. This will give me 5 over 56. Now for the next one, I will get 3 over 8 as before, times, now I've got my odd number, so it's 5 over 7, times, and now I've got 2 remaining even numbers out of 6. Note that the denominators are the same and the numerators are the same but in different order, so my answer will be the same. Similarly, for the last one, to get an odd number, that's 5 over 8 times, and then for an even, I've got 3 out of 7 times 2 over 6. Again, same numerators but in different order, so same result. So if I add these results up, I will get 25 over 56. Let's start part A by writing x equals to 0.43636 and so on. Repeating numbers are 3 and 6. The first pattern starts at 10x, finishes at 1000x. So I've got 1000x is equal 436.3636 and so on. 10x is 4.3636 and so on. And if I subtract, I'm gonna get 990x equals 432. So x is 432 over 990, which simplifies to 24 over 55. Now there are two ways to do part B. Method 1 involves writing square root of 20 as square root of 4 times square root of 5. This is 2 root 5. Square root of 80 is equal to square root of 16 square root of 5. So this is 4 square root of 5. So my original expression, square root of 20 plus square root of 80 over square root of 3 is equal to 2 root 5 plus 4 root 5 over root 3. This is equal to 6 root 5 over root 3. And then I will rationalize the denominator, multiply square root of 3, both the numerator and the denominator. So I get 6 square root of 15 over 3. This is equal to 2 square root of 15. And now I can write 2 as square root of 4 times square root of 15, which will give me square root of 60. Now the second method involves breaking square root of 80 as square root of 4 times square root of 20. So it matches this one. This is 2 square root of 20. So my expression, square root of 20 plus square root of 80 over square root of 3 becomes square root of 20 plus 2 square root of 20 over square root of 3, which will give me 3 square root of 20 over square root of 3. Again, rationalize the denominator. So I get 3 square root of 60 over 3, which will give me square root of 60 as the final answer. In question 18, I will substitute equation 2 into equation 1. So I get 2 times 2y minus 3 squared plus 3y squared equals 214. Then I will expand 4y squared minus 12y plus 9 plus 3y squared is 14. So 8y squared minus 24y plus 18 plus 3y squared equals 214. So 11y squared minus 24y plus 4 is equal to 0. Now you can solve this either by factorization or using the quadratic formula, or if you prefer by completing the square. I will proceed with factorization. That's 11y minus 2 and y minus 2 is equal to 0. So y is equal to 2 over 11, or y is equal to 2. And I will substitute this into equation 2. So x equals to 2 times 2 over 11 minus 3. So x is equal to minus 29 over 11, or x equals to 2 times 2 minus 3. X comes out to be 1. So my solutions are minus 29 over 11, that's x, with y is equal to 2 over 11, or x equals 1 with y is equal to 2. I will start question 19 by finding the upper and lower bounds for p, q, and t. Now p is between 8.35 and 8.45. Q is between 6.25 and 6.35, and T is between 0.265 and 0.275. Now, to find the upper bound for A, I need my numerator to be big, so I will select a large value of P and a small value of Q. And also I need a small denominator, so I will use the lower bound of T. So the upper bound of A will be 8.45 minus 6.25 over 0.265, and correct one decimal place. This is 8.3. I'll start question 20 by factorizing. So I get 4x plus 3x minus 2 is bigger than 0. I will find the two critical values. Those are the values that make the left-hand side equals to 0. So that's x equals to minus 3 over 4, or x equals to 2. Then I'll try and make a rough sketch of y equals the left-hand side of my quadratic. I'm only interested on the x-axis. Now the cutoff points are minus 3 over 4 and 2. I need my graph to be bigger than 0, so I need my graph to be above the x-axis. This is obtained for the left part or the right part, so either x is less than minus 3 over 4 or x is bigger than 2. In question 21, I'm given the graph of a function, and in part A, I need to draw the graph of y equals 2 f of x. Now, this is a stretch by a scale factor of 2 along the y-axis. So basically, the y-coordinates of any point on the graph get multiplied by 2, and the x-coordinates stay the same. And the graph will look like this. I'm given the graph again, and this time I need to draw the graph of y equals f of minus x. This is a reflection on the y-axis, so whatever is on the right of the axis will go to the left and vice versa. For question 22, I'll start with the brackets and try and make it into a single fraction. So I've got 2x minus 5 minus 3, x minus 3 over x minus 3, 2x minus 5. This is equal to 4x minus 10 minus 3x plus 9 over x minus 3, 2x minus 5, and this will simplify to x minus 1 over x minus 3, 2x minus 5. Now, the first fraction can be simplified by factorizing. It's 2x minus 5, 2x plus 5, it's the difference of two squares, over 5x plus 7, x minus 1. So now I can proceed and multiply the two fractions. So let me rewrite them down. Times x minus 1 over x minus 3 to x minus 5. So I can cancel out the brackets that are the same. So I am left with 2x plus 5 over 5x plus 7x minus 3, and nothing else simplifies. So this is my final answer. Now you can expand the denominator if you want, but there is no need. I'm gonna leave it like this. For question 23, I will make a sketch and put this information on the sketch. Now, to prove that points C, D, and E lie on the same straight line, I will need to work 2 out of the following 3 vectors, C, D, C, E, and D, E, and show that they are parallel. If I do that, then C and DE are collinear. Now, first, I will find AB, which is equal to minus A plus B. Then AD is 3/4 of A and B, so it's minus 3 over 4A plus 3 over 4B. So CD is equal to CA, which is half of A, plus A and D, which is minus 3/4 of A plus 3/4 of B, and this simplifies to minus 1/4 of A plus 3/4 of B. Now to find CE, this is minus 1/2 of A plus a whole of B plus another half of B. That's minus half A plus MB plus another half of B. So this simplifies to minus 1/2 A plus 3 over 2 times B. Note that CE is twice C and D, because this is twice minus 1/4 A plus 3/4 B. So CE is equal twice C and D. So CDE is a straight line. In part A, I need to complete the square. First, let's write them in the right order. Minus x squared minus 4x plus 7. This is equal to minus 1, and I've got x squared plus 4x plus 7, which is minus 1. I have not completed the square yet. I'm gonna do that now. That's x plus half of 4 is 2 squared minus 2 squared. This will give me minus 1 x plus 2 squared minus 4. So now I'm gonna expand with the minus 1. So I get minus x plus 2 squared. Minus 1 times minus 4, that's plus 4 plus 7. And this will give me 11 minus x plus 2 squared. In part B, I need to use my answer in part A to solve the following equation. Note that instead of x's, I've got y plus 3. So I will take my answer from part A and replace x with y plus 3. And note also that I've got equals 0. That is what makes it an equation. So 11 equals y plus 5 squared plus of minus square root of 11 equals y plus 5. So y is minus 5 plus or minus the square root of 11. And then in part C, I'm given a formula, an equation y equals 3 minus 5 x plus 1 squared. It has a maximum point at C. Write down the coordinates of A. Now the x coordinate is the value of x that makes the bracket 0. So if x plus 1 is 0, x is minus 1. And if x is minus 1, this disappears, gets 0. So the y coordinate is 3. So minus 1, 3 is the maximum point.